we're back. Now with a soldier, like I told ya. Hey, hey, hey. Let's get started, man. Let's get started. Let's get started. So, if you don't know, I'm Hamish, but a lot of people sometimes they call me Nine River Soldier. You know what I'm saying? You FaceTime here, there's a lot of new ones here. You see right here? Here under. Click, subscribe, follow me on social media, Instagram, and all the other social media, you know? Let's get started. So, this is Exponential. So, let's give Exponential, let's say simplify. Okay. How do I know something exponential? Look, if you have this form, let's say AX. This is the base. You see base, something at the bottom. And this exponential, and all of this is power. This is the base. And this is the exponential. This small number here, exponential, and everything is the power. Okay, so now they give a lot of stuff here. You know, we have to simplify. But first and foremost, you need to know the rules, simple rules. Okay. So whenever you have exponential, excuse me, just I'm gonna run quick. This number here, base, should not be 0. Means it can be 2 power anything, but it cannot be 0 power something. Means it is gonna be 0. You know what I'm saying? So the condition, like for example, whichever number I'm gonna have here, let's say x power 2. You see? So this should not be 0. Oh, my pen, I think. Okay, now let's go to the exponential rule. So we have a product rule because sometimes it can be exponential multiplied by another exponent. For example, 2 power x times 2 power y. So what happens? When the base are the same, you only write 1. Only when the base are the same. And then if there is a multiplication, add the power. So it's going to be x plus y. So this is equal to that. So somebody give, let's say, 3x times, let's say, 16. So you see the base is not the same. But I can break these to be same as that. So this time we say 3 power x. Oh, no. I was meant to say this is 2. So this is going to be 2 power x. And then, so how am I going to make 16 2 power which number? If I have a 2 power 4, we know 2 power 4 equals 16. How? Because 2 power 4 means like 2 times 2 times 2 times 2. Means same thing multiplied by how many times? First time, second time, third time, fourth time. You know what I'm saying? That means 2 power 4. Don't say 2 power 4 equal to 8. No. 2 power 4 means 2 times 2 times 2 times 2. Know what I'm saying? Okay, so for that case now, so I could say 16 is same as say 2 power 4. So you see now the base are the same. So with base the same, I'm only gonna write only 1 and then I add the power. So it's gonna be x plus 4. So you know what I'm saying? Well, sometimes I can give something like this. Let's say this is a 3y and then 81. So I'm gonna think, what I'm going to do now? So let me change this to be 3 power something so they can have the same base, because I know whenever base is the same and then I'm sorted. So this is going to be 3 power 3. 3 power 4, excuse me. 3 power 4, because 81 is like 3 times 3 times 3 times 3. Let's go. 6 times 3, 9. 9 times 3 equals 27. 27 times 3 equals to 81. Oh, so there are 3. How many of them? There are 4. 3 power 4. Oh, now bases are the same. So bases are the same. I'm going to write only 1 and then I add the power. So why? Because there's a multiplication. Multiplication is here. So I'm going to add the power. Say this power plus this. Plus 4. You know what I'm saying? So that's how you do for product rule or for product of the. But only when base are the same. Not all the time base is going to be the same. So if base are not the same, means there's nothing you can do. Sure. Situation like this, for example. So I'm saying somebody give you say x power y times p power x. You see? So these bases are not the same, so there's nothing you can do. So this is going to remain the same. Then how it is. Okay, now let's check some few more. Let's go for division now. For multiplication now we know we go for division. So this rule you see base a power x, a power y. So the base are the same, I only write one base, I add this power, x plus y, x plus y. Okay, now let's go for division rule or quotient. You know what I'm saying? The more you go further, so division means quotient. Quotient. Okay, cool. Now let's go division. So division, only when if base are the same, you take top minus the bottom. Only if base are the same. Only if base are the same. For example, somebody give you stuff like let's say x power y over x power m. Oh, these bases are the same. So base are the same. I only want to write only one base. Take the top power minus the bottom. So it's going to be y minus m. Oh, you know what I'm saying? It's easy. So just remember, if it's a division, you write only one, you take the top power minus the bottom. For example, if somebody give you, let's say 5x plus 3, and they say over 25. So this is tricky. You know why? Because this is not the same base. But I know 25 is like 5 squared. 5 times 5 equals 25. So, this is going to become, let me say, x plus 3. So my intention always try to make base the same. Because 5 times 5 equals 25. 5 times 5 means 5. How many of them? There are 2. So 25 is 5 squared. So now base are the same. If base are the same, I'm only going to write 1. Now, so this is equal to 1 base. Okay? And then we're going to check the top minus the bottom. Always top minus the bottom. So we have x plus 3 minus the bottom. Okay, so now this, let me say, is equal to 5x plus 3 minus 2 equal to x. 3 minus 2 equal to 1. So plus 1. So this is my final answer. If I take this, I'm getting that one. Okay, so quotient also we have an idea. So that's why here they say these bases are the same. Only one base is the same. So I'm going to write only 1a and then take the top x minus the bottom. So for example, they give stuff like this. For example, let's see. Drink a little water, right? Sorry. I apologize. Drink some little water. It says. Cool, let's go. So now they're gonna give stuff like this. For example, let's say this is negative 5 p power 3 over let's say 10 p by negative 4. So now so this is just a number, has nothing to do with the letter because your focus has to be letter. So number is just a number. Negative 5 over 10 equal to, by 5 itself 1. How many 5 in 10? 2. So 1 times, it's like you have a negative 1 on top because this cancels by itself 1. And how many 5 itself 1? How many 5 in 10? They are 2. So we still have a negative, so it's like negative 1 over 2. So this one, you see, base are the same. So I'm only going to write only one base on top and then take the top power minus. So minus always going to be there, but the denominator is also minus. So you say 3 top number minus the denominator, but for this case the denominator just came as a negative, as a given. So this is going to be negative a half. We see half our p. 3 minus minus give us plus, so it's like 3 minus minus plus 4. So this is equal to 1 over 2 p power 7. This is a final answer. You know what I'm saying? Okay, let's take one more example. Somebody say, okay, they get 27 k negative 10 over 3 k square root and then just square root. Okay, cool. Now, so they give us this one now. Let's say simplify. So how about simplify this? Very easy. So first of all, you see, there's a problem here. So this must be written as a power or exponential form because how are you going to write the same base? Because see, there's a root here. This is a big problem, so you must remove this. So first and foremost, it's going to be 27 divided by 3 equal to negative 9. So negative 9, on top is okay, k power negative 10. But at the bottom, it's not k, there's a root square root of k. So let's remove. So if you have a square root of anything, let's say x, this may say x power half. So this is going to become, because remember 27 divided by 3 equal to 9, but there's a negative 9. So here, we're only left with square root of k. So this will be k power a half. So now you see, there's a k, there's a k. So we only write only 1k because base are the same. So negative 9, write only 1k, take the top power, which is negative 10, minus our denominator is a half. So we can write here what? A half. So this is going to give us negative 9, and then we have a k. Now, negative 10 minus negative a half is going to be negative 10 and a half. But if you put in proper fraction, it's going to be you multiply here and here you plus. Improper fraction means if you want to, you might change to proper fraction, you must multiply here, then you must plus. So 2 times 10, negative 20. 2 times negative 10, negative 20, plus 1, negative 21. So this is going to be negative 21 over 2. You know what I'm saying? So if you don't know how to do improper fraction, you can go back to my video of improper fraction for the lower grade, and then you can land there. So this is what you have now. But you know, even though we finished by mathematical, you can leave your answer as a power negative. For example, if somebody give you, let's say this is x minus 6, let's say 1 over 4. You can leave a final answer like this if you finish everything. You have to reciprocate. How you reciprocate? This number is just 1 over 4. And then take where everything is here, it must go to the bottom. It's going to be x, and if it's negative, it's going to become positive. You only change the direction. When you jump border, you write everything, but you change the sign. It's going to be positive. So even if I don't write, it means positive. So same we're going to do here. So if somebody say 8, what is 8? 8 is like 8 over 1. If somebody say 8 over 1, and if somebody say 8 is the same thing, because 8 over 1 equals to 8. So this, why I want to introduce here, I can say this is over 1. You know why? Because anything divided by 1 is that something. 10 rand give to 1 person equal to 10 rand. $5 give it to 1 person, give it to me. What I'm gonna get? $5. Okay? Cool. So now for that case, this is gonna be the same thing. It's not making a difference. But why I'm doing this, because I want to take all this stuff to the bottom. I want to reciprocate. Now let's reciprocate. So we're gonna take this stuff here to the bottom. But only thing is gonna change this side. So this is gonna become -9. It's just -9 over 1 times. But it should be 1 times. This is going to come at the bottom, or you can just take at the bottom. So it's going to become, no need to write 1, or you can write it for 1 times. This is going to come at the bottom, but it's going to become positive. Everything is going to stay the same, but this is going to become positive to the 1 over 2. But 1 times 1 orange equal to 1, 1 times A equal to A, 1 times C equal to C. So 1 times whatever we have is going to be K. So this is going to be -9 over K to the 1 over 2. Now, I think you understand division and plus and whatever you have. Let me show this rule, then we go to the question. Any number power 0 equal to 1. Any number power 0 equal to 1. Any number power 0 to 1. Any number power 0 to 1. There we go. Okay. Okay, let's go, let's go, let's go, let's go, let's go quick. Excuse me, sorry. Okay. Okay, cool. Now, let's go. So, if somebody give us, for example, excuse me, thank you for your patience, thank you for your patience, thank you for your patience. Okay, so somebody give me, let's say this is K, T power 0. So, that's something power 0. What is that power 0? Only T. So, this time we say K, so like with a 0, let's say with a 0. So, it's going to be K times something with a 0 give us 1. So, times 1 equal to K. Somebody give M, B, and all of them power 0 means both of them the power 0. So it's like everything power 0 so equal to 1 means together, because the brackets for together. Now I'm saying, which is different, like if somebody give M, B power 0 times 4. So we know only this is power 0 because there's no bracket. It means it's going to be M times this is going to be 1 times 1 times 4. So equal to 4M. You know what I'm saying? So now let's come, so this rule, anything power 0 equal to 1, let's go to, or skip this one, power. So power is like if somebody give, let's say, 4x y squared, and then here they say 3. So you have to pay attention on your bracket. This bracket means this one is going to have effect of each one. So it's going to be, this 3 is going to come here, it's going to be 4 power 3, x power 3, and the y, so there's a 2 times 3 here, which is going to give us 6. You know what I'm saying? Okay, now for example, somebody give you, okay, let's say m -3 over 4 -4, and here they say 5. So you see this bracket, you must pay attention to the bracket. Or let me do it like this. So you see, so brackets only, so this number is for everything in the bracket but not outside. So this -3 is going to remain the same because it has no effect on the root. Now this m is just m. -4 times 5 equal to -20. Now you come here, this also has effect because this bracket is for both. So 4, okay, so you see 4 and 5 also, power 5. So this is your final answer, you know what I'm saying? Now, the last one, reciprocal rule. How to reciprocate, and then we go to the question. And then when I start to do question, I'm going to be running because now you know all the rule. The last rule is called reciprocal. Reciprocal is like, I just did it before here. If somebody gives us say 4 m power negative 3. Okay, so you can reciprocate this. Okay, so this let me say you only reciprocate the letter. So 4 is just a 4. So you take everything to the bottom of this number here. So this is going to come at the bottom, but you only change the sign. Everything stay the same. So this is negative become positive. That's how you have already reciprocate. You know what I'm saying? So somebody give 5k power 4. Reciprocate. Oh, I can reciprocate. So this is going to be 5, but it's not good to reciprocate a number when it's positive. Always take the negative to positive, but it doesn't matter. For example, somebody say this is negative 4. Reciprocate. What happened? This is going to go to the top. So you can either go to the top or bottom. So this is going to go to the top. It's going to become k power negative 4, but it's not going to be negative. It's going to become positive now. It's going to become positive 4. Done. You only take this to the top. So that's how you reciprocate. Let's check one more. Somebody give say 1 for everything 5 every time 5. Okay, 5x. Okay, so how are we going to reciprocate? First and foremost, you cannot reciprocate. Let's say this is 3. You cannot reciprocate when is the root. So you must write to the power. So we have a 1 on top, and this is going to be 5. So we only this you cannot reciprocate. So it has to be in a exponential form. So this let me say x. You see, if this is 3, so you just flip. You say 1 over 3. See this number 3 over 1. You flip. It's going to come. Okay, so this is just a number. We don't bother with it. But this top must go to the top. So if you go to the top, it's going to be here. But only thing change is the sign. It stay the same, but it's going to change the sign. So that's how you reciprocate. That's why here they say, if you have a here, negative x, that means it's like say 1 over, because here remember there's a 1. So even if they didn't write, but there's a 1 here. So even if they did not write, but there's a 1. So it's like say 1 is there. Take this to the bottom. But if this is negative here, it's going to become positive. Done. You know what I'm saying? So now let's go and do those questions quick. I think you understand all the concept. Now let's go and do those questions. Keep them quick. Oh yeah, like I told you, man. I can start for the last one, so we'll make a special go up. Cool, now let's go. Cool, now let's go. Let's start with this one. So this one, look, there's a multiplication here, even if they didn't give to you. So now look, I'm going to take 2 times negative 3 is going to give us negative 6. Now this is m. I'm going to write m power half, and then we have what? M power 2 over 3. So you see the base are the same. If base are the same, we're going to write only one base, and then we add the power. So negative 6 base are the same, and there's a multiplication. So I'm only going to write 1m. I don't have to write them 2, and then add this power because of the rule. 1 and then add the power if is multiplication. So let's go. So m, and they'll say 1 over 2 plus 2. So 1 over 2 plus 2 over 3. So you can say 1 over 2 plus 2 over 3. So this is equal to negative 6 m. Okay, now this is going to be 3, and this is going to be 4 plus 4 over 6, and this is going to be equal to 9 over 6. No, 7 over 6. Yeah, 7 over 6. See, excuse me. This and this is going to be 3, and this is going to be 4. 7 over 6. 7 over 6, yeah. So this is going to become, okay, say 3 over 4 over 6. Okay, I believe you know how to do fraction. Okay, this 7 over 6. Do not write exponential as a mixed fraction. Don't say this, meaning how many 6 is 7? 1. I'm left with 1 over 6. So the answer goes to 6m, 1 over 6. No, you don't do it, man. Come on, you know what I'm saying? You leave as improper, only for exponential. Don't do like this, you know what I'm saying? Now, let's go for the question number, this one, number 7. So let's do question number 7. So I don't need this, question number 7, let's go quick. Question number 7 is easy. Same game. Question number 7. Oh, let me start question number 1. I'm just going up and down. Question number 1. Because somebody asked me to do this question, so let me start with it. Okay, so we got x power 5 and then x squared and then x power negative 3. All these top are negative 2, and then we have x power 0 and then x power negative 3. So what we're going to do, first and foremost, this equal to 1. Because any number power 0 equal to 1. And this top here, base are the same. So if base are the same, I can just write only 1. I don't have to write a lot of them. And then add the power, because these base same. 2 plus 5 plus 2 equals 7. 7 minus 4 equal to 7 minus 3 equal to 4. Over. This is going to be 1. It's like a 1 times x negative 3. So it's going to become x negative 3. And then we still have for both negative 2. Oh, so this is a division here. So if it's division and the base are the same, unless the base are different, but it's the same for this case. So this means I'm going to write only one base, take the top, minus the bottom. But what is the bottom? Negative 3. But we still have our negative 2. So this is equal to 4, and this is going to be plus, minus plus, so 4 plus equal to 7, and then times negative 2. So now you see, this rule is this one, means if you have something, you can multiply in. So this is going to be x, 7 times negative 2, negative 14. We're done. But it's not good to leave your answer like this in a final answer. You know, so remember there's a 1 here. So this means say 1 over, I'll take this to the bottom, x power 14. We're done with this. Now we go for next one. So I think you can do. I don't know why I'm doing this stuff, because I know you can do all of this question here. Just waste your time here, man. I'm not supposed to waste my time here, man. Why, you know how to do right now, man. I'm supposed anyhow, you know, just here for you. Okay, cool. If somebody say, let's do this. So this is done. Let's go there. Question number 2. So we have a, you see, there's a number and there's no power here. So I can take, okay, let me put, because there's no power here. Okay, so I can take, okay, let me rearrange. So number with the number with the number. So you have a 4, and you have a negative 5, number alone. So numbers done. Let's go to the denominator. We have what? We have a 10. Now, let's go. Let's go for A. So on top, let's start on top. On top we have A. No power means power 1. Another A is A, also power 1. A power 1. Now let's go for B. B squared. Another B, B cubed. Now let's go to the denominator. So denominator we have A. I like to put under A under A. And then B squared. So this equal to, okay, 4 times 5, negative 20 over 10 equal to negative 2. So this is going to give us negative 2. Now, base are the same. I'm going to add this. I'm going to write only 1. 1 plus 1 equal 2, because base are the same. I'll write only 1 and then I add the power again. 2. Okay, now same here. Base are the same. Oh, yes. So I'm going to write only 1 and then add the power. 3 plus 2 equal to 5. And then we come here, we do the same again. Okay, now this and this we get negative 2. This. So I don't have anything here. Now this is going to be A squared and then B squared. So this is like the same thing. So this, let me say negative 2. Base are the same now for division. I'm going to write only one base, and then I'll take top minus the bottom. And then here I'm going to write only one base because they're the same, top minus the bottom. So this is equal to negative 2. A power 0 because 2 minus 2 equal to 0. And then B 5 minus 2 equal to 3. So this is equal to negative 2. Any number power 0 equal to 1. So times 1 times B power cube equal to negative 2 times 1 negative 2 and then B. Oh my god, done. Let's go to the next one. So that one is done. We go to this one. I'm not supposed, I mean, come on guys, you know this stuff, man. Come on, but let me just do it for fun. But I know you know. Okay, so now we come here. So this is x. Look, so there's a power outside, means you must multiply in. So 2 times n to n because there's a power, and this is going to be y. 2 times n is 2n. Now we come here, but remember bracket is for both. Even the denominator also has effect on that because this bracket is also to the denominator. So I'm going to go a 2 times n to n. Why? Because this bracket is everywhere. B 3 times n is 3n. So now we go the same game. Okay, is this an x? Do you have an x at the denominator? No x. So means this does not have any friend. So it's going to say the same. Now we come for this one. Does this have any friend? No. So we become y to n. Now we come here. Does this have any friend? Maybe denominator, no. Numerator, no. So we're going to say the same. But I can do some little extra. You know what the little extra I'm going to do? Look. This stuff here. No, it's fine. You can leave like that. It's okay. You know what I'm saying? You can leave like that. And it's acceptable. Just a minute, sorry. I'm drinking some water. Okay, now we want to go for that one. Number 4. Question number 4. Question number 4. So I'm drinking some water. Okay, cool. Excuse me, sorry. Okay, cool. Now, so we're done with that. Now we go for question number 4. Question number 4 is very easy, guys. So you see, this is for both. This is it for both. So I'm going to say A. All this times 6, so it's going to be 3n minus 9, but both of them times what? Times 6. Times 6. Now we go to the denominator. But you see the bracket is only on top. So this is not going to have an effect with 6. No, only on top. So the denominator is going to be A, 2n minus 4. Okay, cool. Then after that, see the base are the same. So I'm going to write only one base. And then is division, remember, so I'm going to take this minus this. So it's going to become 6, 3n minus 9 minus the one other denominator. Put your bracket, always put your bracket. It's going to save your life. 2n minus 4. So this is going to become a. Now let's minus this so we can just go outside and work on this and get an answer, and then right here on top. So now we got 6. 6 times 3, 18n. 6 times negative 9, negative 54. Now minus times 2n is going to become, because look, minus times this is going to become minus 2n. Minus and minus is going to become plus. Okay, and then 4, which is 4. Okay, so 18n minus, because the sign of n numbers on the left. 18n minus 2n equal to 16n, because when you take a number you must take with the sign on the left. So positive minus 2n equal to 16n. Negative 54 plus 4. Negative 54 plus 4 equal to negative 50. So this equal to negative 50. So this half is going to be written here on top of A. So finally, if I subtract these two, it's going to give me this, which is going to be written on top of A. So finally, A, and then write 16n minus 50. I think we're done. No, we left with question number 7. Question number 7. And we're done with exponential for this case. So maybe another example will show you some tricky part of exponential. Okay, cool. Now we go. So this, when somebody say, for example, 6 divided by 4, this same say 6 over 4. Same thing, over meaning division. Okay? Oh, they kind of change in exam. I just saw like to say division, but I was like, what is that? So the same thing. You know what I'm saying? Oh yes. Let's go. So now, if they give me this, I can say this over that. So I'm gonna rewrite. Let me say 12. Okay, square, and then m power 8, but both power 2 over that 4 km power 16. So now first and foremost, there's a problem here, means these must be multiplied in, because the bracket for each number. So we want to say 12 square. What is 12 square? 144. So it's going to be 12 square, but if we take 12 power 2, we're going to get 12 times 12 equal to 144. Now we come here, k power 2. These two, you multiply this, is going to give you 2 times 2 equal to 4. So k power 4. Now we count for the last one. It's m. 8 times 2 equal to 16 over. We have a 4 and they have a k m power 16. So now we can finish up. How we gonna finish up? 144 divided by 4. Okay, now we got 144 divided by 4. I think 36. Yeah, 36. I believe so. Okay, 30. Yeah, 36. Okay. So this is gonna give us 36. I mean number 144 divided by 4 6. Now we go for k. These bases are the same, so I'm gonna write one base, which is k and k. Take top base. There's no power here, means power 1. What is the top base? 4 minus the bottom base is 1, and then we go for m. M is gonna be m power 16. We minus the same thing because the same power, same exponential. So 36 k power 3 and m power 0. But 16 minus 16 equals to 0. But any number power 0 equal to 1. Okay. So times 1, it's like times 1. So 36 k power 3, because anything multiplied by 1 is that something. 1 orange times 1 equal to 1 orange. 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 We gone. We're done. We're done. Ah, we are. Roja, like I told you.